The registration for September, like I just said, has started. So if you all are interested in just getting the timetable and whatnot and the prices, right? You just ask your parents just to WhatsApp me, and by tonight, I'll be able to reply and send it and whatnot, right? And they can have a look at the timetable, prices, and they can make a decision if they want to sign up in September. All right, so just that, and let's get started from where we left off last week. How much of you all can agree this was the last slide you all saw last week? It seems familiar to me as well, right? Sahana, you say yes. All right. Great. So we're almost at the end of alcohols. Last week, you saw a lot of, well, reactions involving alcohols. And remember, I asked you all to try your best to write it over and over and memorize it, right? That's the only thing you can really, really do. Next on the list is some uses of alcohols. Now, believe it or not, like I said last week, there are many different types of alcohols, but when we usually talk about, when people hear the word alcohol, the first thing that jumps into their head is consumable alcohol. But really, in truth, only one type of alcohol is consumable by humans, and that's ethanol. But remember, it have other types of alcohol: pentanol, methanol, right? Butanol, so many different types. And this over here is a summary of all the uses of alcohols. And this will be enough for the CXC syllabus. Believe me, you just learn off these 3 types and you're set for the exam in this category. Take it down, and of course, let me know when you are finished. I'm not going to explain it too much. I think the wording did a pretty good job already, right? But read it and then write it at least. Right, so like just for recording purposes, I made a mistake here. This is supposed to be the word as. All right, so you have 3 uses of alcohols there for you in case the examiner asks you. Let's move down now. Now, over here, we're going to talk, before I go all the way down here, right? The alcohol we're going to be talking about here is 2 types. Well, alcohol abuse basically deals with the consumable part of alcohol. The consumable alcohol is ethanol, but some people also drink methanol, which is really, really not a good idea. And well, you all would know, but alcohol is a really, really addictive substance. And of course, it's commonly abused. Now, there are short-term effects of alcohol abuse, right? A lot of them, you could have guessed it even without me telling you, from, observing other people or hearing stories and whatnot. Well, when you drink too much alcohol, your reflexes get slowed, your speech, a person who is intoxicated, they don't talk fluently, right? They usually have slurred speech, and sometimes they don't even make sense, right? A lot of memory loss happens, and sometimes if you drink too much alcohol, you get unconscious, right? You go unconscious. So these are like short-term effects, everything in the green box, right? Those effects usually last about 24 hours to 48 hours, and after, hopefully the person is normal after that. However, if you consume alcohol or abuse it for a long period of time, you get something called cirrhosis of the liver. They usually call that the hardening of the liver. And of course, you all can Google it to see how it's not a pleasant picture of how your liver looks after years and years of drinking too much. And of course, you can suffer from hypertension, that's like high blood pressure, and you definitely will get some nervous disorders, right? Chronic alcoholics over the years, they're very fidgety. If you watch their hands, they're always trembling and whatnot, right? The nervous system gets weak over time. So at the end of the day, do not drink alcohol. All right, take down the short-term and long-term effects of alcohol. Let me know when you are finished. After alcohols, most likely your teacher is going to move on to something a little scary looking, something called alkanoic acids. And remember how alkenes and alcohols had a general formula. Well, alkanoic acids also have a general formula, and you will know it from a mile away, right? It is always have a COOH at the end. Remember, alcohols is just have a O and a H, but alkanoic acids that have COO and a H. And here are some examples of alkanoic acids. And if you look at the structure, you'll see that the COO and H. And this is how it is written, but this is how it's drawn. So all of these are examples of alkanoic acids, right? And the tutor is telling you it's really easy to identify. Now, all alkanoic acids end with ethanoic. So you'll remember the prefixes, like this one here is what? Has one C, so he is methanoic acid. Real simple. You think y'all can do the draw and do the rest for me? You just have to count the amount of C's, figure out what the prefix is, and then add the words ethanoic acid. As simple as that. Right? Let me know, but feel free to send your answers, right? Right, so answers are correct. So the second one is 1, 2, and 3, right? So that's propanoic acid, right? And the next one is 1, 2, 3, 4, 5. So this one is pentanoic acid. Of course, you have to memorize this formula, right? I think by now you all understand how to use the formula. Like if you replace the letter N with 1, you can predict how much H's and whatnot the whole structure will have. Okay. In different textbooks, the formula might look a little different, but believe me, even though the formula looks a little bit different, it will still give you the same value of C's and H's if you use the formula. All right. So don't get confused if you go in a textbook and see it slightly different. That's normal. I went through the same thing. Enough time. Let's move down and see what's next on the list. So now we have to do some reactions of ethanoic acid, and you are going to really be helping me out today. By now, everyone should have gone through the videos on how to balance an equation. So usually when I give you the reactions, like when I was doing alkenes and alcohols, and there were various equations, I just wrote it out for you, and I even balanced them for you. Today, you're going to be helping me with the balancing part, okay? So the reactions of ethanoic acids can be broken down into 2 categories, and you're seeing some strange words here. Anhydrous, which means whenever you hear the word anhydrous, you could think of it as without water. So anhydrous means without water. So I guess it doesn't mean it's not a liquid. It just means it has no H2O in it. And whenever you hear the word aqueous, well, you can think of this as with water. So some of the ethanoic acids, right? Ethanoic acid is a liquid. So sometimes, believe it or not, you could be a liquid and have no water in you. And of course, some of the other reactions are going to involve liquid ethanoic acid, but it's going to have water mixed into it. So just take down the 2 categories and don't let the fancy words bother you. One just means without water and one means with water. Obviously, there are many reactions of ethanoic acids, but the CXC syllabus doesn't concentrate on all. It's just a few of them, a few categories it will concentrate on, which is good news for you. Less work to memorize. Let's moving down. All right. So because it's ethanoic acid, like I use the word acid, I just want to quickly just review what is an acid, right? What makes an acid an acid? Let's say I have water, right? And a popular example of an acid is HCl, right? Hydrochloric acid. But there's a little misconception here. HCl, if I put the letter G, it means that this is a gas. The HCl itself, hydrogen chloride, you really don't consider that an acid. It's not an acid yet. What we need to do is take some water. And of course, we are going to put the HCl inside of it. What's going to happen with the HCl? The HCl is going to split up into two things. The hydrogen becomes disassociated or separated from the chlorine. The hydrogen has a positive charge and the chlorine will have a negative charge. An acid is anything that has an excess of H+, we call this a hydrogen ion. There are many definitions of what an acid is, but to me, this is the simplest thing. An acid is anything that when you dissolve it in water, you get an H+ ion. If you dissolve something in water and you do not get H+ ions, it is simply not an acid. Now, acids is a huge topic in chemistry. I'm just giving you a grain of sand here on the explanation. This is a whole topic by itself, okay? So I'm gonna put a little note for you here, right? The H+ ions, the hydrogen ions, I'll put in brackets to H+, makes it an acid, right? So the reason I'm explaining this to you is because we're doing ethanoic acids. So at some point in time, when you're doing the reactions, we're supposed to see a H+ ion if it is really, really an acid. Let's move on. Let's look at some. Right. So let's look at some anhydrous reactions. The first one is this. We're not going to be doing two at the moment, right? We're just doing this one. The first one is, apparently, you can take ethanoic acid and burn it in air or oxygen. Now, you're combining what? Ethanoic acid and oxygen at the end of the day. So at the beginning of the experiment, there's no water involved. It's just pure ethanoic acid. That is why I'm calling it anhydrous. Now, some of you probably spot this already. You're seeing the word water, but I just said anhydrous deals with no water. But when I use the word anhydrous, I mean there's no water at the beginning. The two things are mixing together initially. Afterwards, out of no fault of yours, you got carbon dioxide, water, and heat. So here's what I need for you all to do, right? I need for you all to write a balanced equation. Let me start you off. It's ethanoic acid. So I'm going to start you off with CH3, COOH. And you know this is an ethanoic acid because you're seeing COOH and it has two C's. 2 means F. Now you're going to add oxygen, right? And see if you all can balance the rest of the equation for me. Take a shot, right? You might get it wrong. Just try your best. That's all I'm asking. When this is balanced, remember, oxygen is diatomic, right? Did you all have this? A 2 here, a 2 here, and a 2 here. That should be the balanced equation there. Right? If you got it wrong, not a problem. Just, take down the correct. The reason it's a liquid, right, and not AQ, AQ means it's dissolved in water, right, to make it AQ. But remember, we said it's anhydrous. Remember we said that at the beginning? Anhydrous means it does not have any water in it. So you didn't take the ethanoic acid and mix it in water as yet. In other words, it's pure ethanoic acid, but we're still calling it ethanoic acid because we know if we were to dissolve it in water, it would have the potential to form an H plus ion, right? So I hope that answers the question of why we use the letter L and not AQ, because it's anhydrous. All right, so the next one is this. Now, I just want you to memorize this for the time being. Whenever you take anhydrous ethanoic acid and you mix it with alcohols, we did alcohols last week, you get two things, an ester and water. You see, we need an entire class to discuss what an ester is. This is probably one of the hardest things to teach in organic chemistry. And like I said, we need about a full 2 hours to go through esters and understand exactly what an ester is and to learn its general formulas and how to draw it out. But just memorize this for the time being. And sometime in September or October, we will do esters. All right, so we're going to kind of move on now to the aqueous reactions, right? So when you see the ethanoic acid over here, right, it means that the ethanoic, since it's aqueous, we're taking the ethanoic acid and we kind of dissolve it in water, or we add water to it. That's going to be understood in this here. But even though it's, we have water in it, we're not going to write the water part. It's just going to be understood that it's dissolved or in water or whatnot. So the first one you have to memorize is that whenever you take ethanoic acid and you mix it with a very reactive metal. Now, you're probably asking yourself, what is a reactive metal? There are many different types of metals on the periodic table. It has sodium, it has magnesium, it has lead, it has iron. I could go on and on, right? There are many different types of ions. Some examples of reactive metals are like sodium and magnesium and calcium and potassium. Things like iron and lead, even though they are metals, they are not considered very, very reactive. And the reactivity of metals, being able to classify them, whether they are reactive or not, is an entire chapter in your CXE chemistry book, which we don't have time to do today, but just learn off these very popular examples of reactive metals. So let me start you up here. So apparently, when you take ethanoic acid and you add any one of these reactive metals, you're going to get two things, a salt and hydrogen gas. Okay, so some of y'all probably don't know what a salt is. There are many different types of salts in the CXE, in chemistry, right? So that's an entire topic by itself. So anyway, let's get started. So we are going to take ethanoic acid once again, CH3, COOH. Oh, sorry, I write it in the wrong place. Write it up here. CH3, COOH. We're going to add a certain metal. Let's just take magnesium. Now remember, the magnesium is going to be solid magnesium, and magnesium is in group 2 right, in group 2, which means when it combines with something, its charge is going to be 2 plus positive 2. And you get salt and water, right? I'm sorry, salt and hydrogen gas. So I'm just going to put H2 gas here. And the salt will need to go here. So for those of you who are familiar with salts, you can try to complete the reaction there. Let me get clear a little bit more space here. I need plenty of space. Right? And remember, hydrogen is diatomic. So get started. That's right. Since this ethanoic acid, we dissolve it in water, it will split up into 2 parts. Check this out. Remember, I tell you, an acid, if you dissolve it in water, you're supposed to get an H plus. This is what happens. CH3COO. And you see this hydrogen, he gets kicked out of the structure. So when you dissolve it in water. Now, quick question. What's the charge on hydrogen? Like when hydrogen combines with something, what will be its charge? +1, +2, +3? Do you all remember? Right. This is a very standard. It will always be +1. But if you just put a positive sign, the 1 is understood. So if these two things were combined, remember the charges have to be equal and opposite. So what would be the charge on this entire structure here? It would have to be -1, right? Remember, if you have two things combined in chemistry, like you have two things, A and B, if the charge on him is +2, then the charge on him has to be -2. They have to cancel out. So if you know the charge on hydrogen is positive, then the charge on this entire remaining structure, as complex as it looks, its overall charge boils down to minus. Okay? All right. And what's going to happen in this reaction, the magnesium, he sees the hydrogen separated and he says, aha, I'm going to take his space. So you see how the hydrogen is over here? He's going to get kicked out, and guess who is going to take its place? Mr. Magnesium. So it's going to look something like this, right? Let me get a different color here. I can just use the white. So it have CH3COO, and this H, right? He gets kicked out to form hydrogen. Remember, if hydrogen gets kicked out and he's on its own, you cannot have one hydrogen by himself. So you have to put H2. You have to. And who takes its place here? Mr. Magnesium. But tell me something. Magnesium is in group 2. So his charge will be +2. But his charge is what? Minus. Are these two a match? Can a +2 combine just so without any help with 1 minus? No, it cannot. The charges have to be equal, which means and you need 2 of these guys here to balance out the magnesium. So you have to put this entire thing in brackets and put a 2. So that way it have 2 minus signs now, okay? So the 2 of them are balanced now. Now in the exam, you can't put this and you can't put this. Well, when you join the 2 of them together, you're not really supposed to put the charges on top. I have no idea why. To me, I would be so happy if every textbook would put the charges on top. That would make it easier for me to understand, but they don't, right? But here's the thing, right? This not balanced, because remember, when it kicked out the hydrogen has to be H2. You have no choice but to write that. So to balance it, what did you all do? I think you had to put a 2 over here to balance it out. That looking correct? You had to put a 2 over here. So you have 2 H's over here. So when you kick out this H, is really 2 H's getting kicked out. I think this one is correct now. And this over here is AQ. Right? So let's see. We're going to take ethanoic acid again, CH3COOH, and we're going to add, let's choose an oxide, right? It's going to be the same basic reaction for oxide or hydroxide. And let's just take copper oxide, right? And what you're going to do, we're going to get a salt. Now, how the salt will look, right? The salt, for it to be a salt, whatever metal you have here, like how we had magnesium here, it would take the place of the H. So to create a salt here, the copper is going to have to steal the place of what? The H. So who is going to get kicked out? The H and the O. Because if the copper and this piece going to get married, if two of them going to get married, then he and he going to be what? Single. So they're going to have to go on his side by themselves now. And the H and the O will combine to get what? Water. Think of it like that. I don't know if you can use the imagination, right? But the point is, the H and the O get kicked out and they will form what? Water. And this time the water is a liquid. All right, so see if you can formulate this salt here. Now, in case you didn't know, copper has a charge of +2. So it's going to be a similar situation like this one here, because he is 1-, copper is 2+. You need 2 of him to balance out 1 of him. Right? Let's see what goes on here. So you have the CH3COO, and copper kicks out Mr. Hydrogen, but he's not compatible with him. You need 2 of him because copper is +2, right? I'm trying to get the state symbol here. The state symbol here will be aqueous. Right, so I hope you all had that one correct. A lot of people did send the answers and they were correct. So we're on to the next one now, the third one. Ethanoic acids plus a carbonate or hydrogen carbonate. In case you don't know what a carbonate is, I have some space on top here. A carbonate is anything with CO3, and hydrogen carbonate is what? HCO3, right? The point is it have a CO3 in it, carbon and oxygen in it. So let's take ethanoic acid again, because you see the syllabus is only going to ask you about ethanoic acid itself, right? It's not going to really ask you about pentanoic acid for all of these reactions, right? That's all right. 1 second. Small mistake. I forgot my 2 here. I suppose I have a 2 over here. So thanks. Somebody reminded me. I'm trying to figure out. Carol, thank you. Right. All right, so let's move on to 3 here. So we're going to take the ethanoic acid again. CH3COOH. We are going to add a carbonate. Let's add sodium carbonate. And now here's the thing. The carbonate has a charge of 2-. And remember, sodium is in group 1. So he has a charge of +1. So if I take sodium carbonate, it will look like this. Are these 2 a match? This is supposed to be sodium carbonate because I want to have a type of carbonate. Are these 2 a match? What do you all think? He has a charge. That is no, Jodel, that is not a match. Look at this. Carbonate has a charge of 2-. Sodium only has a charge of 1+, +1. The 2 don't cancel out. So that means I will need 2 sodiums, Na2. 2 sodium means it has +2. Now they are a match. Okay. I realize I need more space here. It's a long reaction, right? So. And apparently, when you mix these 2 together, you're supposed to get a salt, water, and carbon dioxide. Now, water is easy. He's just H2O, and I have the carbon dioxide here. You just need to get the salt part. Once again, for it to be a salt, Mr. Hydrogen is going to get replaced by the metal. Look at all of them. Mr. Hydrogen got replaced by the metal. Mr. Hydrogen got replaced by the metal. It's the same scenario, okay? But the good news is sodium has a charge, one sodium has a charge of positive. So he is compatible with the first part of the ethanoic acid. Because remember, he has a charge of minus, right? So see if we can figure it out. Throw away the H and replace it with what? The Ne. Answers coming up. So what happens here is that the CH3OO is fully compatible with one sodium, right? It's fully compatible, right? But we have a little problem because we started off with 2 sodium here. So you have to put the 2 in front here to balance it off. And if you do that, you can realize, wait, now everything is balanced. So just double checking it. Want to get my state symbols correct. EQ here. Over here, it's liquid. And here's our gas. All right. EQ here and EQ here. I think it's correct. I'm double checking it. I make mistakes every once in a while. Right? You all can confirm it too. I forgot my 2 here, and you all are correct, and thank you for correcting me. All right, guys, so this is pretty much the end of class. And of course, don't forget the sign up for September has started. Just ask your parents or WhatsApp me, and I will send them all the info. And I apologize once again for today's short class.